In level 2, we will be solving basic exponential and logarithmic equations. And the way you will do this is always by changing the form. So if you have a log form, you're going to end up changing it to exponential form. And if you have an exponential equation, you're going to end up changing it to log form. So I'm starting with an equation in log form. You always want to make sure that the log is isolated before you change forms. The log is all by itself in this case, so I'm going to change this to exponential form. But first I'm going to remember that when I don't have a base written in a log, that it's log base 10. So this really means log base 10 of 3x minus 2 equals 2. And this whole log is by itself right now. There's nothing outside of it. So I'm good to change it to exponential form. And to change it to exponential form, I start with the base, which is 10. I raise that to the second power, that's my exponent, and then I set that equal to this whole expression, 3x minus 2. And then now I have an equation that I can solve. 10 to the second power is 100 equals 3x minus 2. Add 2 to both sides and we get 102 equals 3x. Divide by 3 and we get x equals 34. In this next example, the log is not isolated yet. So this natural log of 2x plus 1 needs to be by itself before I change it to exponential form to solve it. And to get it by itself, I have to divide both sides by -4 to get rid of that -4. And we get natural log of 2x plus 1 equals positive 3. And now that I have the log part isolated, I'm going to change it to exponential form to solve it. And the natural log, remember, means log base e of 2x plus 1 equals 3. And now I'm going to change this to exponential form. To change it to exponential form, I start with the base, which is e. The exponent is 3, so e to the third power, equals, and then I set it equal to this whole expression, 2x plus 1. And now I just have to solve for x. I can't simplify e to the third, that's just some weird number, but I just leave it like that. So I subtract 1 from both sides, and we get e to the third minus 1 equals 2x, and then I divide both sides by 2, and we get x is equal to e to the third minus 1 over 2. And that's the exact answer. You could also find a rounded answer by plugging that into your calculator and getting a decimal approximation, which is approximately 9.54. This next example is an exponential equation, and I'm going to solve it by converting it to logarithmic form. First, before I do that, I need to get the exponential part by itself, so the 10 to the 5x needs to be all by itself before I want to change it to log form. So I need to get rid of that -2. So I have to start by dividing both sides by -2. And I get 10 to the 5x is equal to 520. And now I can change this to log form. I get log base 10, and remember we don't really want to write in the 10, we just write log for base 10. Log base 10 of 520 equals 5x. And now it's in log form. And we're trying to solve for x, so to get x by itself, all I have to do is divide both sides by 5. So I get x equals log of 520 divided by 5. And that's a weird looking answer, but I have x by itself, and so that's the exact answer. Log of 520 divided by 5. And to get a rounded answer or a decimal approximation, you're going to plug that in your calculator. And when you plug it in your calculator, just make sure that you close the parenthesis around the 520 before you divide by 5. And you get approximately 0.54.